Everyone, thanks for coming in. And I am Murugappan Chetty. I work as a principal engineer at Optum, and I work on serverless, service mesh, and observability there. I'm also a small-time open source contributor. So about my company, Optum. Optum is part of United Health Group. Just like how United Healthcare provides health benefits, Optum provides health services for United Health Group, I should say. And Optum also works with a wide variety of customers across the healthcare domain, and you can see some numbers here. So that's about my company. And today I'm going to be talking about how we set up a serverless platform in my company and how we are currently managing it, what are all the use cases that we are running. And if the time permits, I'll also show a small demo. So how did we get started? Back in 2016, we had to develop some Alexa skills. So these are some live skills that we have developed, and for which we had to use AWS Lambda. That was our first exposure to serverless, and we really liked the experience. It was really simple and powerful. So, and we thought how it would be to bring it to an on-premise platform and show it to our enterprise customers. So if we had to do that, the things that were on our side was majority of our workload is on-premise. And the container system, container ecosystem was kind of mature at that time. We were already on Kubernetes and OpenShift. And we had like a lot of compelling use cases within our company which could come on the platform. And we were also aware that it would be always compared with a public offering like AWS Lambda or Google Cloud. And we had to prove the cost effectiveness compared to a vanilla Kubernetes or OpenShift. So that being said, around 2018, early 2018, that's when we started. And we compared about like 6 open source platforms. I'm not going to mention those. If anybody wants to know about what other platforms were, we could have a discussion after this session. And based on that, one common factor between all of them was everything was container based. So the functions or the service would run as a container and scale up and down. So based on that, we set some principles for ourselves. So most important thing, it should be request based compute, and scale to 0 is the main one. And we were already having a solid Kubernetes-based platform. So our platform, we wanted to run it on top of Kubernetes. And it should obviously support all the programming languages, even PowerShell or shell script. And observability, we wanted it to be a first-class citizen. And this ecosystem was really evolving. Now also the serverless ecosystem is rapidly evolving. So living and learning was always part of the culture. The two actors that would be involved in this is an operator. Operator is the one who's going to be building this platform and hiding all the complexity. And the users are the one that's going to just develop some functions or services and be just concentrating on the business use case. So keeping these principles and actors in mind, we put together some capabilities that we wanted to form a serverless platform. So, or I would call as a part of the puzzle that would make the serverless platform. So first one, and this one is the core of the platform, is the build, event, and serve. That is the 3 pillars of any serverless platform. So building is the way that we give to our developers to build their functions and functions or services. And serving is the function management lifecycle, so scaling up, scaling down. And for eventing, how once the service is deployed, what are all the ways that service could be reached. And for all these things, we used an open source platform called Knative. Anybody here aware of Knative or already using it? Yes. Okay. So I'll talk about Knative in the next few slides. And for multi-tenancy, for any managed serverless platform, the most important thing is multi-tenancy. Fortunately, Knative and Kubernetes both are multi-tenant by nature. So with Kubernetes RBAC and integration with the token provider, you can clearly segregate the roles and have multi-tenancy. Security is, in the microservice world, security is usually developers' concern. Developers usually take care of the security for their own application, but we wanted to give this as part of the platform itself. So for which we leveraged Istio's RBAC and Istio's TLS capabilities. And we want to have observability and resiliency as first-class citizens, which I'll go over in later slides. So Then eighth one is the one that we developed in-house, and we wanted to give that extra level of convenience for the users so that they feel at home with this platform. So that we call it actually as a serverless dashboard. And these are a set of APIs, which I'll go over, like what are all the set of APIs and what abstraction it provides. And along with it, comprehensive set of documentation and CLI called KN CLI, which is also part of the Knative project. So these are how the platform stacks up. I think it's really small, but what all the components involved are like Kubernetes, Istio, Knative, and on top of that, we have that serverless dashboard API that we have, and we use Keycloak for the token provider, and our observability stack consists of Prometheus, EFK stack, and Jaeger for tracing, and so that's it. So, okay. Now I'll go into the components. So what are all the components involved, and I'll just go and see like how we are using it. Yeah, Kubernetes is our base, and we all love Kubernetes. I'm sure most of you are already like know what Kubernetes does. But here I'm just going to talk about to write a service in Kubernetes, what does it take now? So we have to write two manifests. One is a deployment, and another one is a service. And what it lacks currently today is like there is no per request load balancing. Auto scaling is just based on HPA, and there is no concurrency control, meaning that there could be like thousands of requests concurrently coming and hitting in the same pod at the time. So this is where Knative comes in actually. Okay. So here, Knative is a popular open source project actually, and it has like more than 400 contributors from 60 plus companies, and mainly it's a collaboration between Google, VMware, IBM, Red Hat, and SAP. The community is really good actually, and everybody is welcome there, and the Slack channel is very active. And even the Knative serving lead once posted that asking dumb question is a superpower, and we have unleashed it many times there. And Knative comes with like three main, it used to come with three components actually: serving, eventing, and build. Build is now discontinued for Tecton pipelines. So serving and eventing are the main two components that we are concentrating on. Serving is kind of really matured, and it is multi-tenant by nature. So main feature of Knative serving is a control plane. Its job is to scale the pods up and down in a tenant namespace. So whenever user gives a manifest to create a service, Knative deploys in the user's namespace, and then whenever the request comes in, the pod goes up or down. It's all controlled by the Knative control plane. And obviously there's a queue proxy, which is a sidecar which sits along with the user's container, which gives all the information related to the container, when to scale up or down. All those information is fed by the queue proxy. And related to auto scaling, there are two auto scaler controllers that they provide. One is request based, and another one is CPU based. So you can choose either one of them to auto scale your services. And for networking, they use a gateway, external gateway. It could be either Istio or Glue, and they also support a gateway called Contour or Courier. Currently, only activator is part of the your request path. So once you have deployed the service in the Kubernetes namespace, and only during the cold start, the activator comes in your request path. So once the pod is up, the calls directly go from the Istio ingress gateway to your application. Knative control plane is not anymore in the request path. Okay. Any controller that comes inside Kubernetes, we know there are going to be some CRDs. Knative also comes with its own share of CRDs, but the CRDs that we need to be aware of is mainly the service. The service comprises of like encapsulate three other CRDs within. One is revision, second one is configuration and route. Revision is an immutable object. So when you create a service, when you create a Knative service similar to a Kubernetes service, a revision is created, and that means like that is immutable. And anytime when you update your container, a new revision will be created. So if you want to go back to the older version, you can go back to that revision. Also, you can do A/B testing between these two revisions, or any kind of canary deployments between these two. Also, the traffic, you can adjust the traffic between these two revisions, like if you want to go 50-50, 70-30, like that. And the route is the CRD that's going to have the traffic related information. configuration is a single object, and it's going to have the current state of the Knative service configuration. So that's about Knative. And Knative uses, as I told earlier, Knative uses Istio for its networking purposes. It creates services in this format, like service name dot namespace name dot the domain name. So we configure our DNS in such a way that any request to start.domain name should be routed to the Istio ingress gateway. So the Knative expects Istio ingress gateway or the cluster local gateway to route the traffic based on the host header information to the correct service. So, and that is one thing. And the additional features that we are expecting out of Istio is TLS. So the TLS handshake is managed by the Istio ingress gateway. So we load the wildcard certificate as a secret, and Istio ingress gateway has a component called secret discovery service, which discovers the certificate from the secret and handles the TLS handshake for you. Currently, Knative is developing something called Auto TLS. It's kind of in alpha. What Auto TLS does is, like, whenever you deploy a new service, it's going to generate the certificate automatically for you with the help of Cert Manager. So the way it works currently now is the certificates are wildcard certificates. With Auto TLS, you will get the certificate per service. So while showing the demo, I'll show you how it looks. And the other two security aspects that we look for Istio is authorization and authentication. Istio can check a JWT token for who is the issuer, and it can also check for the claims, and based on that, you can protect your services. So the maintainers of Knative, when they developed and released it, how they are positioning it is like as a low-level set of primitive APIs. On top of that, they could build some high-level user-friendly APIs. So that's what Google Cloud Run is doing on top of Knative, or a Project Kaima from SAP is doing, and Red Hat is also bringing something in the OpenShift. And so for our customers internally, we built a set of APIs, and we call it like serverless platform APIs. And it mainly concentrates on 4 areas. It's highly opinionated for the company. And first one is tenant space management, where the users can come in and create their namespace, add users, set the kube context. Second one is like, this is the most important thing, where the users can create services, do canaries, add authorization. And the last one is function tester. So where the user has to, if this component was not there, the user has to know about Kubernetes, Istio, and Knative, and know about all the CRDs and all those things. We are just abstracting it and making it a little bit easier for them to get started with this platform. And with this set of APIs, the user doesn't need any kubectl or Kubernetes dashboard. And this API also enforces good standards, like you always need to specify your CPU in memory. That is a problem with any Kubernetes operator. You ask people always oversubscribe and ask for more CPU in memory. So this is kind of a standard that we enforce. And all the functions or services are run as non-root. And we also enforce versioning. So in Knative, when it does resource versioning, either you can give your own resource version name, or you can ask Knative to generate one. So we enforce to give the resource version name. So when it comes for backup, it's really helpful. And these APIs are also goes well with our inside Jenkins libraries that we have. So the next one is we spent a lot of time on getting metrics and logs, right? Because when we say people don't have to access kubectl or Kubernetes dashboard, the metrics needs to be really well organized. So my friends here who have come along with me, Vay and Somadeep, they are also they were instrumental in building this metrics setup actually. So the problem here is like Kubernetes doesn't come with any metrics setup, but we can set up Prometheus for Kubernetes to scrape the metrics. Istio comes with its own set of observability components. Knative comes with its own set of observability components. We have to consolidate all those into one. So that's what we have done here. For Istio, we can define a service monitor and then get the metrics into the Prometheus operator. For Kubernetes, same, we define some service monitors to get it in the Prometheus operator. And for Knative control plane and the user metrics, we define some custom scrape configs to get it in the Prometheus. And for long-term storage, we use Thanos, backed up by object storage. And we spent a lot of time with Grafana dashboards to make it really simple for the users and for the operators to get to know what's going on within the cluster. The next thing is Knative does comes with this EFK stack as it is. They give you the template to just deploy it in your Kubernetes cluster. You can just take their Fluentd configuration and use it, but the way Elasticsearch and Kibana works, we need to play around with something. It doesn't work out of the box. So we did some work on that, and now all the logs, only the user container logs. And you know, if I try to scrape every single Kubernetes logs, it's going to be like too much. So we are just scraping the user container logs and into Elasticsearch, and we visualize it using Kibana. Okay, so once the platform is all set up, the next thing we need to see is like, how are you going to manage this platform? For which I'm going to just touch about 3 areas which we mainly concentrated to check on the platform. First one is like planning for the capacity. So once you have your platform up and running, you need to know when you want to upgrade the resources, when you want to add more nodes. So we have a single place of in the Grafana dashboard where we could see exactly like how much resource is being utilized and when we need to upgrade. So always during increasing more resources, we had to back it with correct facts. So this is the Grafana dashboard that we have. Second one is to monitor our cluster, for which we have like 2 ways. One is a Grafana dashboard and Prometheus alerts, which we have customized for our cluster. And we have also developed a probe tool, which is very extendable, which probes at different points of the cluster and currently says what is the status of the cluster. And slowly, if we see repeated issue, we also add automation to it. For example, for certain issues, it is worth restarting the node. We identify those kind of issues, and automatically node get restarted without letting the user know. Of course, it sends an email to us, but those things are automatically handled for us. Like this, like if there is an issue happening again and again, we just filter it out and then take corrective actions automatically. And third one is like for the user. We have developed a simple dashboard which tells like how many functions they have or services and how many times they have run it, and what is the CPU and memory utilization for their functions. Okay. It's about any platform without user is not much useful to the company. So we spend a lot of time make the users feel at home. So we develop like comprehensive guides for them to get started with. We mainly concentrate on 2 areas. First one is like building and deploying, how we can help them. Second one is how to observe their functions. For building and deploying, the main thing is, as I told you earlier, containers. The Knative platform expects a Docker image to run it as a function. So people are already familiar with Docker. It's easy. They can just get started and they can work on it. But we wanted to get people who are not familiar with Docker, but still we wanted to pull them in. So for that, there are like multiple tools currently available. I'll just touch on something. Okay. For the Google Container Platform has 2 tools. One is called Co. Second one is called Jib. Okay. So Co is for building container images for Golang, and Jib is a Maven plugin or a Gradle plugin for Java. And Fabricate is also a famous plugin from Red Hat, which is also really good. And these are 3 plugins we mostly use, along with another CLI called OpenFaaS CLI. OpenFaaS is also open source serverless platform. Their CLI is really good because we could just, it comes with a set of templates for a wide variety of languages, even shell script or a PowerShell. So infrastructure people who would want to just put some functions here and don't have much knowledge on Docker, they use the OpenFaaS CLI to develop their Docker images and deploy it here. We are also checking on Tekton pipelines and build packs, which is like growing right now. And when it comes to deployment, we have like 2 opportunities. One is the serverless platform APIs that I told earlier. So these are a set of APIs that we offer. And so here it just asks for very less number of variables to get started with. You just need to give the name of the service and the image name and which port it runs. and you're going to get an URL for you to get started. And there is also a KN CLI which comes with Knative. This CLI is like really powerful. You can get the same, but instead of kubectl, you're replacing with KN CLI. That's it. You can get started quickly. So this is the dashboard that we built for the user. So here in the front, you can see the number of times the function run, and then how much CPU and memory it's using. And you can see here clearly that the CPU spikes and goes down every interval. So this is a periodic function, and then every time it's not used, the CPU and memory usage goes down. Okay. Next, I'll just go over some use cases, early adopters for the platform. First one is the infrastructure automation use case. For this one, it's based on a pattern called three-factor pattern, coined by people at Hasura. Hasura is a GraphQL engine. So that's the GraphQL engine we're using, and it's a GraphQL engine on top of Postgres. So three factors that they are mentioning here are GraphQL, eventing, and serverless. So when a user creates a request for infrastructure automation, so this is mainly concentrating on decommissioning a server. So whenever they want to decommissioning a server, they use this. So when a user comes here and he says that he wants to decommission his server, there is a request to the GraphQL engine, and it persists that in the Postgres database. So based on that, an event is triggered, and all these functions are called. And these functions do some action, and then they persist again to the GraphQL engine. So right now the user is still waiting on the subscription. So when there is a change happening, it is reflected on the UI. So this is the first use case, and it's currently running in production successfully. Previously it used to be a manual effort, and we automated this one. This is a common use case around most of the organization, file processing. And file processing usually is done with the ESB solution. And we were also doing this with a commercial ESB solution, which we re-architected using this platform. And we used to share the store in Kafka. And currently we are trying to re-architect using this Knative eventing. I didn't go over Knative eventing. In the end, I'll just touch upon what Knative eventing is. So this is another infrastructure use case, or this is a common pattern across my company, whoever has Prometheus. So based on a Prometheus alert, functions are triggered. So whenever there's a Prometheus alert for some action, each alert is mapped to a function, and that function takes the action. So when there's an alert, it goes to a message queue, and the message queue triggers the function. So this is another use case that we are trying to re-architect, use the Knative eventing. Serverless is kind of synonymous with IoT, because IoT is also event-based. And in the data ingestion pipelines of the health devices, we are using Knative here. So finally, this is a machine learning use case. So we have a couple of machine learning use cases. What it does is there's a machine learning model this service uses to process the data that is being sent inside. And you can see here, we did some benchmarking with it. You can see here, if it was supposed to run on just a container platform without serverless, it would be always consuming this 5 GB and around 2 or 3 CPUs. It's a constant one. And this use case, they didn't have request constantly 24/7. So when they used to get it, they used to get it in loads. So that's why they changed it into a serverless platform. And when we did it for a 5-minute time, the pre-serverless one used to process about 50 transactions. In the serverless, we were able to process around 400 transactions. Other prominent use cases are mainly the infrastructure people kind of love it actually, because who are maintaining these large machines, they have these small jobs running here and there. There's no centralized place to put it. Now all these services and functions are running inside this platform. It's a centralized place for them to manage. And we have a lot of ETL jobs as well. There is a couple of voicemail processing services running. Serving MN models is the other one that we are looking into, but with KF serving become generally available, we'll be looking into that. Okay, so these are challenges related to the serverless platform itself. Like, it's not just related to the platform that we have, it's common to any serverless platform. DB connections to database like MySQL or something like that. Every time the service comes up, it will establish a new connection. If you are using any NoSQL or a Cassandra or something like that, it's fine. Now we are not having any problems. We are mostly use SQL database. But if you use a traditional database, sometimes we have this connection pooling. There's no connection pooling. That's a problem. So how we mitigated this is like we used to have a stateful microservice which will handle all the database connections for those functions. Second one is like a culture problem. The default resource allocation, people always ask for like more resources. And this is like with more metrics, and we were able to help the users say that you are asking like 2 GB or 3 GB, but hardly using like 100 MB or 200 MB. So it's more like a culture thing. Cold starts are always going to be a question for any serverless platform. The best way is to mitigate them, and Knative is also taking a lot of efforts to mitigate this cold starts. For long-running functions, in this platform, I mean, you can run functions like 3 hours or 4 hours, but we really need to make sure that it's stateless. So if you're going to store the state somewhere and then keep on running, that's not worth it. You just need to change it to a microservice or something like that. But if it's not storing any state, just processing and keeping on running for 1 hour, we currently allow them to do it. Java functions was another problem. The reason is like mostly all the microservices that were earlier built were using Spring Boot. Spring Boot is really good for microservices, but it really takes time for starting up, and by default itself it takes some memory. So how we overcame this was like using a framework called Quarkus. Quarkus is really a great framework. It is based on GraalVM and Hotspot. It starts in about like milliseconds. You can build binary images for Java, and you can compare the memory usage for Spring Boot application connecting to a Cassandra database. It takes about like 270 MB, but here it takes hardly like 20 MB, and it starts in about like 0.4 seconds. So whereas the Spring Boot application would start in 20 seconds. Okay, and before I go to the demo, these are some of the points that I want to stress. Timeout with Knative is configurable. You can configure as much you want, but there is you need to fix on some time, and you should say because it's not ideal for storing state, and you should enforce that the applications are stateless. And there is no way to mount a PVC also. Knative makes sure that you cannot mount a PVC. The only volume that you can mount are configuration maps and secrets. So there's nowhere you can store state within the application. And while upgrading the Knative or Istio to a newer version, what we found out was sometime when we deleted the CRD by mistake, it deletes the resources also. So it's a good idea to back up your resources. And we also developed a small tool to back up the Knative resources just before upgrading the Knative services. And finally, about eventing, with all the open source serverless platforms that are available today, it is either it's only invoked by webhook. Okay, so in the webhook, the problem is like consumer doesn't have a say. Only the producer keeps on hitting the service with the webhooks, and the consumer doesn't have a say. That's where the cloud events come into play, which gives a proper way to define your events. And with Knative eventing, it gives a proper framework for that. And the producers can produce without even the consumer coming and consuming it. So that kind of framework is given by eventing, and any consumer can go to any producer and get that event from it. The another project that we are like closely looking into is like Kubeflow, which I don't have a lot of information right now to tell. Okay. So I just want to show a small demo. This is not about the platform, just about why should I? How should I bring it in? I got out, man.
The other side.
Which side?
Maybe that.
There's only one, right? Oh, okay. How should I make it big? Oh, I cannot see it from here. Okay, so I have Knative and Istio installed in this Google Container Platform. And what I'm going to do here is like deploy a sample service which is going to get the Twitter trends from Twitter API. It has two services. First, one service is going to return the where on earth ID, and the second service, which is the main service, going to return the Twitter trends for us. And oh my God. Oh, it's really hard to do it from here. Okay, so I'm going to use the core CLI here. So this is my K8 YAML actually. Okay, let me apply that. So all I do is like co-apply. How you used to do the kubectl apply K8.yaml, you can do co-apply K8.yaml, which is going to just build the image and then as well as like deploy the Kubernetes for us. Oh God. I cannot see it from here. Oh, Docker is spelled wrong? No, I'm just putting co here. Okay. Okay, so it's building the image. So it takes the base image as the Dristroller's image that Google gives, and that's it. It's building the image, pushed it, and as well as like run the image for me. So these are the two services that you can see in the bottom. So one, you can see automatically there's HTTPS, so the certificate is there, and that is the service that I'm going to call. And second one is the internal service, which is not accessible to the outside world. So it has the end as .service.cluster.local. So that's why it doesn't have a certificate. How can I? I want to go to the top, but I'm not able to go to the top. Come here. I want to minimize this, man. Minimize.
There you go.
Hey, what's wrong with you? To enter it.
Sorry, demo bots. Yeah.
How does it go? I moved there. At least put it in this thing, browser thing. Okay, go to the next one. Go to the next one. Oh, okay. Okay, this is calling the function, I think. Yeah, this is calling the function to, it's starting up, so that's why it's spinning. And it'll print you the Twitter trends for you. So at the same time, you can also embed, so this is the Twitter trends for you. And at the same time, you can also embed multiple endpoints. So any other serverless platform that you see, right? So they'll be just in a single endpoint. So now you can have like multiple endpoints in the same service. So one that gives you the Twitter trends, one there is you can also embed a Swagger, or you can also have multiple endpoints for you. And this demo is actually in this GitHub page. So what I told earlier was like, if you see this K8 YAML, this is my deployment artifact. Oh. And you can see the image names are just the direct GitHub source paths, not the Docker repo. And so code just needs Go source path. So whatever is in the source path, it's going to compile and then create an image for you. Okay, that's it I have. Any questions?
So, questions?
So your service scaler, Kubernetes already has the ability to do service scaling, dynamic service scaling. Is there a reason you didn't use the Kubernetes service scaling, or?
The HPA, Kubernetes HPA?
Yes.
So the Kubernetes HPA is kind of slow. So we use the Kubernetes autoscaler for the platform components, but Knative itself comes with a set of autoscalers, which are like more fast than the Kubernetes scaling. Yeah. Okay, so it's based on your use.
You want to repeat the question?
Yeah. So how do you mitigate cold starts is the question. So it's based on your use case. Suppose if it is going to serve a web endpoint, a web, then it is always good to have one pod up actually, whichever is your main pod that needs to be up, and then scaling can be handled. And otherwise, whichever is the calling application always needs to have some kind of retry mechanism, retry with pushback. Sometimes it doesn't start within 60 seconds. If it's going to be a huge machine learning image and takes a lot of time to pull and start, then it's better to have some kind of retrace. So these are the two things that we used actually. Otherwise, for other ETL jobs, you don't worry about like cold starts. So it's going to be run in the night, and you don't mind about it.
Thank you.
No problem.
You mentioned a bit about Prometheus scraping. So how does Prometheus, what kind of scraping Prometheus does for the serverless function that people roll? Like what kind of key metric do you guys monitor on? Because it's like a short-term kind of thing. It's not like a long-term running process. So how does that work?
So first thing is like it is always up for like 30 seconds, and our scraping is for like every 3 seconds. Just for the user containers, we scrape for 3 seconds, and this scraping is user, if he wants, he can add a Prometheus endpoint also, but we are scraping from the sidecar container metrics called the Q proxy. It just has the information about like how many times the request came and how much CPU memory it has, like very limited memory. That is provided by the platform itself. Okay.
And how does the the development experience looks like? So if I'm a serverless developer, right, and I want to develop against, the Knative stuff, do we have to install all of the moving parts, like Istio, the Knative operators, Kubernetes, or you guys spin up like a development environment so then developer can work against it? So how does that work? How do I test? How do I run?
Okay. So there has to be an operator managing the platform for you. So the developer, for Knative to run, it needs Istio and it needs Kubernetes, it needs all this setup. But it is a managed platform that a single team can manage, and you as a user can leverage that. So that's what we are doing in our company. So there's a small team of like 5 people managing this platform, and this whole company is like taking use of it. Correct. So all the developers are going to just call this, yeah. So that's where we have this namespace segregation in Kubernetes, right? So in Kubernetes namespace, we add role bindings, which are mapped to each role binding has a user information, which is mapped to the token that they provide when they log in. Okay.
Oh, okay, hold on.
Did you use all the supported products, or did you do everything yourself? Istio and Keycloak integration, for instance?
Yeah, we just did it, we took the open source version and we did it on our own. Yeah. Yes, on our own. Yeah. But there are good documentation available for Istio and Knative.
And it includes Keycloak as well.
Yes, Keycloak we had to set up. Yeah, Keycloak is we've been using Keycloak for more than 2 years, and initially it was tough. Now we have kind of like okay.